Welcome back for another episode of the 5G Guys. I'm Wayne Smith, and I'm joined by my co-host, Dan McBall.
Hey, everyone. Welcome back. Thanks again for listening. Great to have everyone back. Hey, today we're going to talk about wireless charging. The future is going to be here sooner than we think. Imagine someday never having to plug in your phone or other devices to charge them. That inevitable future is coming, and we're going to talk about it today with our guest, Cherif Chibane. Cherif has been researching and developing communication systems for over 30 years now. He was involved in development of 3G, 4G, Wi-Fi, and other commercial applications, as well as other systems for the military. He was a research scientist at MIT Laboratory and Draper Laboratory, where he led research in advanced space communications, as well as aerospace and guidance and navigation. He's a lecturer, research scientist, technologist, and entrepreneur with broad and deep experience in advanced technology development for entities including NASA, DARPA, and other major government laboratories. He's also a former adjunct professor at Farley Dickinson University in New Jersey, where he lectured on advanced engineering topics. And he also mentored and advised his students on their undergraduate and graduate level work. Today, Cherif serves as the Chief Technology Officer for WIGL. That's pronounced wiggle, like you wiggle in your chair, but it's spelled WIGL, and we'll talk about what that is. But WIGL is leading the industry in the charge to make wireless charging a reality. So Cherif, thanks for joining us. We're excited to talk about WIGL and what the future holds for wireless charging.
Thank you for having me.
So I guess before we dive into the future, let's talk a little bit about the history of transmitting energy without wires. As I understand it, that whole concept started with Nikola Tesla way back in the mid 1800s. Is that right?
Yes. Yeah.
So he was actually, a funny story, near the town I grew up in. There was a town called Manitou Springs, Colorado, where he actually had a laboratory where he was running experiments to do just that. And the town fathers got so upset and concerned with all of the crazy stuff going on that they actually kicked him out of town, and he had to move somewhere else. So I actually learned about Tesla very early in my career and my strive to become an electrical engineer. But the reality is those early experiments and things he was doing has really led us to where we're at today. Is that right?
Yeah. Actually, he was the first one who tried this concept long time ago. And just I just mentioned something very, very quick. He used this physics concept, which is when you take a current, you put it through a coil, you induce magnetic field. And then if you take a coil and put it in magnetic field, you create current. See, this is duality that exists between current and, from one end to the other end. So he used the same concept, trying to send power from one point to another point. Yes, he is really the pioneer and the one that thought about this concept originally.
And so that's really the concept of induction, right?
Exactly, yeah.
Right, okay. So if we take that to where we're at today, I think some of us are familiar with, there's some really rudimentary wireless charging capabilities today, right? Like you can buy a charger where you don't have to plug your phone in, you just set your phone on top of the charger. So exactly. Is that using inductive charging? Is that what's going on?
Yeah, that's right. That is exactly. So if you look at all the power devices, anything that you plug in the wall, there is transformer in there. There is the primary coil and the secondary coil. So what we do is in the primary coil, the power comes from the wall, goes through the coil. And then the secondary coil sees induced electric field, and then from it generates the current, which gets processed to make you the DC. So that is right now in the transformer. What you see these days is basically they took the two coils, the primary, the secondary. The primary, they put it on the base, and the secondary, they put it on the phone. But it's the same concept.
Got it. So what you guys are doing at WIGL, I guess first, before you tell us what you're doing at WIGL, tell us what WIGL stands for, WIGL.
Yeah, WIGL stands for Wireless Grid. So basically what we're trying to do, allow you to treat power as you treat Wi-Fi now. Wi-Fi, you use it to get data. Mm-hmm. We want to do the same thing where you get power anywhere you want and at any time. So that's WIGL.
Oh, okay. So it's a play on Wi-Fi, but you replace
Exactly.
the FI with GL. Okay.
Exactly. Yeah.
Okay. That makes sense. Great. So maybe give us an introduction. What is the foundation of what's unique about WIGL? What you envision for WIGL in terms of the basics of how it'll work?
Yeah. Yeah. Okay. So as I said before, this concept is not new. So there are obviously there are some people working on this topic here. All the people, I should say, the majority that I know of, they're working on basically what we refer to point, meaning, because remember, as I was explaining, the coil, you have the primary, the secondary. The primary, you can think of it as a transmitter, and the secondary, you can think of the receiver. So you have one side that transmits power, and the other side receives it. So most of the people are working point to point, meaning you have one transmitter and one receiver, and the receiver basically sits there. He sees the RF coming to it from the transmitter. He takes it, he converts it to DC, and then he powers it. The problem there is a law in physics where the farther you go, the farther the distance between the transmitter and the receiver, the less energy you receive on the receiver side, which might not be enough. Right. So that is really the challenge that Tesla's had before, and that we're trying to solve now. So right now, the people who have transmitter and the receiver, that means you're fixed in terms of distance. You have to be in the same place and sit there, and you cannot move. You can move a little bit. Our concept, we solved that problem, and that's really the key of our technology.
Hey, so is WIGL a nonprofit? Are you doing research? Or
No. We are a for-profit.
Okay.
We founded about 3 years ago, and it's funny how we came. Excuse me, I'll take a couple of minutes because it happened. I didn't expect it to happen at all, and it just happened. So I was at MIT Lincoln Lab. I was doing research in the area of wireless communication, and we were doing work for the DoD. And there was another fellow who's the CEO, Dr. Glover, and he was on the government side trying to see what we were doing, working with us at MIT. And then my son moved to New York, so we had to move to New York. I left Lincoln, and I was kind of trying to see what I can do. So he heard I left, and he came to me. He said, "Cherif, I have this idea of wireless charging. What do you think?" And me, as a wireless guy, when you talk about wireless, we talk networks, we talk base stations, and so on and so forth. So what I did is I took the concept and I applied the cellular concept, meaning different cells to give you a network to cover a larger area to allow you to move farther. We wrote a patent. We applied for a patent. It was accepted very fast. And since then, we're at the third prototypes, and we were on Start Engine. You can go there on the Start Engine. You see us over there where we raised some funds over there. So we are a for-profit.
Nice.
So the big difference then from what the past and where we're at today is instead of inductive transfer of energy, we're literally using radio frequency waves the same way that Wi-Fi does. And in fact, if I understand correctly, you guys are actually doing your initial prototypes using the same spectrum as Wi-Fi, right?
Absolutely, yes. Yeah, right now what we're doing is we're using the 2.4 gigahertz for our testing, although the industry is trying to see what other frequencies. So we're using the 2.4 frequencies. We had two options. We can use the 2.4 or we can use the 900 megahertz frequencies. And these two frequencies are free to use. So the reason we opted for and it's funny because at 900 megahertz, what we refer to in our field, the propagation losses, meaning the loss of energy, is less than at higher frequencies. That's why, if you've noticed with AM, you can hear it farther than FM because the FM frequency is higher. So what we did, and also, and in our case, if you're targeting handheld devices, it turns out that lower frequencies, the size of the antenna is bigger. So we opted of using 2.4 gigahertz to allow us to use the receive antenna to be smaller. So this way it will be very easy to be incorporated into handheld devices. But our technology is really, we call it as frequency agnostic. We really don't care where we can transmit, but the current demonstration, the current prototypes we're building are at 2.4 gigahertz.
So basically, if I understand correctly, in the future with this technology, there would be charging access points spread throughout a building, like say a shopping mall, the same way Wi-Fi access points exist today. And as I'm walking through the mall with my phone, as I walk past an access point, it would associate with it. And instead of getting data service from it, like we do with Wi-Fi, it would get charging service from it using the same RF energy. That's effective way. And then as I walk, it would just hand off and continue to get charged by other access points.
Yeah, exactly, Dan. You had it right. That's the same concept of cellular network. Remember initially when I wrote the patent, cellular network is the same thing, right? You have base stations at different areas, and then as you're walking, if the next base station, you make connection to it, and as you're moving, you go to the next one, and we say what we call roaming or handoff. The same concept, we use it over here. So you can what we envision you have transmitters distributed in different areas. Could be the malls, could be airports, could be anywhere, and then your device, on the device side, you'll have a receiver. And that receiver there is looking, and whenever he sees a transmitter then nearby, he can make a connection to it without even you knowing about it, and then he starts receiving power and charging the battery. And again, the same concept as Wi-Fi. I mean, for all of us who remember the old days, when we needed to access the internet, we have to bring a wire and go somewhere where the internet is and plug it in and listen, right? So that's the same. Now we just use Wi-Fi. We don't even think about what it is. So the same concept we're trying to do right now. So we're using our transmitters now, but in the future, when technology improves, we believe that we can piggyback receiving the energy from Wi-Fi, from 5G base station, or from anything that transmits RF in the air.
Oh, wow. So what you're saying is that in the future, you'll be able to have one antenna or access point and transmit alongside of Wi-Fi broadband, and it'll just happen simultaneously. So you'll get data and power from the same antenna configurations.
Absolutely, yes. That is kind of that's it.
Hey, real quick, let's take a quick break to thank our sponsor, Vertex Innovations, for making this episode possible. For over 17 years now, Vertex has been building the nation's wireless and broadband networks. They provide project management, network engineering, and construction oversight, just to name a few things, for their clients. So if you're looking for a partner to help you with your wireless network, whether it be design, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's VERTEX-US.com.
Now, also another thing and by the way, and this has a huge benefit to us, to users, to humanity, to everything, is because, I mean, and this is, I didn't know about this until we were doing testing, and I discovered it. It turned out the iPhone, for instance, if you were to charge it, it requires a lot of current in there. And the reason they do that is because they want you to charge once and then hopefully not charge again in 2 days. They don't want you to keep charging every 2 hours, right? So they put in a bigger battery and all the costs that associate with it. They need to change it. So that's now if you have our technology like ours, our technology available over there, you can think of the ether around you as the battery. So you no longer need to charge. Maybe you need a very tiny one to charge, to keep a little bit charge in there. And then since the RF that allows you to power your devices is all over the place, so you really do not need the super duper battery, which has many benefits. As I said, first of all, you can make the device cheaper. You can, and also another thing, and you guys are very familiar with the 5G. When we talk 5G, we talk about Internet of Things, we talk about handheld devices, we talk about sensors to be embedded in future infrastructure, bridges and everything. all these devices, they need batteries. Now, the Internet of Things alone, they're talking about maybe 20 billion or 30 billion in the next 5 years or something. Handheld devices. So all these batteries that we have to deal with in the future, a technology like this will certainly help in using fewer of them.
Wow. So when you say that, it also doesn't this translate to maybe health related devices that need to be
Absolutely.
charged? Yeah.
Absolutely. Yes. Yeah. The Internet of Things, one of the biggest driver is the sensors that monitor the health. And yeah, that is, I mean, in the future, what I envision is you can go and put sensor in there to embed it in there to does something, monitor something and send the information back to the doctor. And you don't need to go change the battery or anything. If you want to charge, you connect to the RF and it charges itself. Yes, that is one of the potential application for this solution.
Yeah, that's a really good point. I mean, the demand for rare earth metals that are required to make batteries is
Yep.
a huge issue, right? There's
Absolutely.
a very limited sources of rare earth metals. They're very toxic and expensive to mine. And I've wondered, as we continue to have more and more electronics requiring batteries, there's got to be a break point. And so I could see this, to your point, if we need smaller batteries in every device, that'll allow us to have a lot more to go around. So that
Absolutely.
never thought of that. That's a really good point.
Yeah, that is one of the things that this technology brings in. Also, in addition, what it does is, I mean, the reason we're talking about this is because of the explosion of communications, right? Because if we didn't have communication, if we didn't have all these handheld devices, all these sensors, we were not talking about this. But the communication, and you guys are in this field, and what did the wireless communication brought to us is it allowed us to have communication anytime and anywhere. Mm-hmm. Right?
Yeah.
Before the wireless, it was only any time. Before everything else is, if you needed to talk to somebody, you have to get on your horse, go over there, meet him wherever he is, tell him whatever you need to do. He tells you, come back, right? Then we had the phone, wired phone. The wired phone is you can talk to him anytime, but he has to be at a certain place, mm-hmm. right? With the wireless, you can talk to him anytime and anywhere. So that's really the problem is now we still need power. Yeah, I can talk to you, and we all know I travel a lot, and when we go to the airport, and usually the place that has a crowd that you see too many heads, that's where they are charging their devices.
Mm-hmm.
It's very interesting. This technology would definitely foster more adoption of wearables. One of the things, one of my gripes is, I have an Apple Watch and there's some conveniences there, but it's not a convenience. You have to charge it every day. Mm-hmm. You know what I mean? And so I opted for another brand like Garmin. This watch lasts 48 days and it charges itself somewhat through solar. And so my adoption to the technology, and I think everyone's adoption, will be greater, which then will improve health and other aspects when you're checking it on a more regular basis. So great. It's a great application, not only just for the wireless device, but for health and wellness in the U.S. and across the world.
Yeah. Yeah, and just a cost alone, because if you think about it, the handheld device, and I did some Googling, maybe the battery costs $5. Let's say just $5. I don't have any basis for it, but just assume it's $5, right? So if you have 20 billion unit devices, that's just the battery alone, not counting the logistics and the guy changing it and all of this. So it's going to be huge. In addition, which I think Dan and we talked about the other day, is in addition, once you have the battery, you can make the electronics truly wearable. You can make them conform with the body, whatever you need to do, which is going to be, and I will argue that you will not need to charge the electronics as often as we do today. So it is truly a game changer. There are some challenges we need to solve, but I think when this happens, it is going to change the way we live, the way we do things, the way we monitor our health, among many, many things.
Mm-hmm. Yeah. And I mean, we're just talking about the consumer facing benefits. I can imagine that there's a lot of benefits, for example, in the Defense Department.
Oh,
You've got soldiers in the field that there's nowhere for them to go plug in for all of their
absolutely.
wearables that
Yeah.
they're right. The Defense Department now has wearables where they can monitor every single person in the field, where they're at,
Yeah.
what their health is. I got to imagine this is a huge mover of the needle for that kind of technology.
Oh, absolutely, absolutely. The DoD or the military, one of their biggest headaches is the logistics for batteries.
Mm-hmm.
Where do you get them? Where do you charge them? And they have too many batteries. So we are actually one of and this is public domain. We announced the demonstration that we're doing with a company called Cubic, and this is common knowledge. And they are a DoD defense contractor. And what we're doing, we're using our technology, trying to do a demonstration to demonstrate, to show how good our technology is. So we signed with them, and we're in the process of doing the demo. Hopefully, we're going to announce the results.
That's awesome.
A question that comes up, I think, is your technology, is it as small as what Wi-Fi is, or is it large? Does it take space? Is that some of the things to overcome?
The size, believe it or not, the electronic is really, really small.
Oh, wow.
But, the electronic is nothing. All it is, for the engineers out there among your listeners, is just a couple of diodes, because what we're doing is you have an AC, a signal changing, you have a diode, you rectify it, the same concept we use to do power supplies. The challenge here is you have to have the antenna that's large enough to have enough area to be able to receive the RF. That's really the challenge. So obviously you want to make it as big as you can to allow to have more RF hitting it, so this way it can capture it. But the bigger you make it, it might not fit into small devices. So that's kind of really, but really the electronics itself, it's not really much.
Got it. So here's a question. And when I was telling my wife that you were going to be on, and I was kind of geeking out with her about the technology because I love it. The first thing she said to me, she goes, "Well, gosh, that sounds dangerous." I'm like, "What do you mean?" She's like, "Well, because in her mind, she's envisioning when she thinks about power, she thinks about like the kilovolts of energy going down the transmission line on that big tower behind the house or whatever, right?"
Yeah.
She doesn't think about it like low power radio frequency communications like we know it is.
Yeah.
So talk a little bit about that kind of question that people might have about the safety and the health issues as it relates to this technology, if you will, and how you guys are addressing that.
Yeah, so that is that's an excellent point, and everybody asks that. They think that by doing this, and by the time you walk through it, you fry and everything. No, that's not true. But we are using the demonstration we're doing now. We're using the same power level that are per what the FCC Part 15. FCC made the rules and saying the same ones that are used in the cellular network in handheld devices. So you can tell your wife, and my wife, I tell her the same thing. That's the same thing. So right now we're all walking in the Wi-Fi area where you have RF all over us and everything. So that's kind of what we're doing. What we're trying to do is that the challenge is if you use the same band as the Wi-Fi and you have a lot of them, you might interfere with the Wi-Fi signal. That, to me, that's another thing. So there is an industry body called something Alliance, I forgot. We just joined them, and they are working with the FCC, trying to come up with what frequency to use and how much power you're allowed to send. But the power that we're using now, that everybody in this field are using, are basically what is similar to the Wi-Fi and the cellular networks.
Oh, okay.
So they have not to worry about it.
So basically, your phone is already receiving a signal for Wi-Fi or for cellular or 5G,
yeah.
And it's just we're going to use that same level of signal for power instead of communication. So it's no different than what we're already used to today.
That's right. That is our intent and our goal. Yes.
Yeah, it seems like that a wireless carrier would jump all over this in order to provide extra value. Not only are we giving you high-speed connections to broadband, we're also going to power all your house and your devices. Seems like it would be a great combination for one of those guys.
Oh yeah, absolutely, and especially now with the deployment of the 5G, because one key element of 5G, you have the density of the base stations a lot higher, right? So you're gonna have more base stations per areas compared to the 4G. And yes, when you have that infrastructure deployed, you can use that to provide services as we do right now. I do believe that, and we're in the process of talking to some potential people in this area that they see definitely a need. And this is an extra revenue stream for them because ideally they're going to reduce the cost of the devices, and B, they'll be able to charge the same way they charge now for Wi-Fi. Because I tell you, for one, I would be willing to pay something so I don't have to worry about finding the wire and the right one and sitting there and charging it. I can pay $1 a month or something, but think how much is and this is just the cell phones. Another thing that, and Wayne, you probably can relate to it, is another area is when we build bridges, we embed sensors in there to monitor the health and the vibrations, and we're starting to do it in all infrastructures. So those sensors there, when you put the bridge, you put in there for 20, 30 years, you don't want to keep going and digging and changing. So this technology will be useful in those type of things as well.
Yeah, it's fascinating. So Dan hit the last one. I mean, this is a great.
Well, I just want to know when do you think we're going to see this actually become reality? Like, I want it today, and I know it's early, right? It's inevitable. It's going to happen.
It is inevitable. I think by if I were to put my future looking hats, probably maybe I'd say about 2025 it will be. Right now, you need the Apples to adopt it.
Mm-hmm.
You need this because it's a chicken and the egg thing, right? Mm-hmm. So and they're starting to look into this technology, and I think from my reading is the Far East people seem to be a little bit ahead of us here. So as soon as one of those companies adopt it, then there's nowhere to stop with it.
Got it. So you need all of the big guys, all the big manufacturers like the Sonys and the Apples of the world to adopt it. And like I said, it's inevitable that they're going to. And the hope for you guys is that it's your technology that they're going to hitch their wagon to.
Yeah, of course. Yeah, we hope. And right now what we're doing is our technology, and again, this is public domain, is we're building what we call some type of sleeve, where you take your iPhone and put it in the sleeve, and it's mounted there, and then and then it collects power. This way you don't have to. And the next one is we're trying to build maybe chipsets that hopefully those are the things that where we need the Apples and the Samsung to take them and embed them as part of the device. So this way, when you buy the device, you don't have to worry about power. You don't have to worry about anything. Everything is there, and that's what I see the progression, because the manufacturing guys will not adopt it until they really see a clear need. I mean, we know it's going to happen, but the question is who's going to push the first button. And of course, we hope that our technology will be one of the winners.
Mm-hmm.
Wow. Yeah. Well, thanks for joining us and sharing your wisdom. It's clear telecommunications and wireless in particular have been a big enabler of, this technology. And it is amazing sitting here, Dan, with all the ideas. When we do the podcast, Dan sent it over, and I am super fascinated about just the practical application to make everyone's lives better and getting rid of the cords. We have teens at my house, and we're continuously fighting over, did you steal my cord for the phone charger? I don't know where they disappeared to, but they definitely disappear rapidly in a house full of teens. But Dan, I'll hand it back to you. Thanks, Cherif.
Yeah, Cherif, thanks so much for joining us. This has been awesome. I look forward to staying in touch, and tell us how our listeners can get in touch with WIGL and you, or any websites or anything they can go to if they want to learn more.
Yeah, we have WIGL. We have also, for some people who really need to to read more about our technology, we just published a report in Nature magazine.
Okay.
That's really a good one because it's not really too technical. It has a little bit technical, and it explains how our technology and how our benefit is. Of course, on the website, you have Start Engine, Google WIGL, and you will see the people that invested in us. So those are the three things. Of course, we are going to be announcing a few things that hopefully in a couple of weeks, I'll send you something and it's going to announce some really cool stuff we're doing.
Well, that's awesome. Yeah, we'll look in the show notes. We'll put links to the WIGL website, to the Nature article. Maybe we'll even put a link to the press release on your stuff you guys are doing with Cubic on the DoD side. And yeah, we'll definitely keep track and keep our listeners updated on the progress because it's exciting.
Absolutely.
Well, awesome. Well, thanks for everyone for joining us again for another episode. Remember to subscribe or follow the show, tell your friends about it, and go to 5gguys.com to engage with us more. So we love hearing from everybody with your ideas and feedback. So take care until next time and be well.
Thank you. Thanks for having me. Bye-bye, guys.
Bye.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.